while I was looking into curvature math and looking into stuff like this, I came across an interesting word problem, which, ironically enough, absolutely nullifies the entire Ball Earth thesis. And it does so using their math. Check this out. All right. This is a website called mathcentral.euregina.ca. I'm not sure if I pronounced that right, but whatever. Anyway, you see the URL here. So they're talking about how can I find the curvature per mile of the Earth's surface, and they give an answer right here. And they say after you do all the long form math, it ends up being 7.98 inches, or like we said, everybody's just kind of rounding it up to 8 inches per mile. All right, but then it says look at our response to Shirley to see what happens after the first mile. So you click on this, and there's an interesting question posed here at the top. There are two 6-foot men. What would the distance be between them before one could not be seen because of the curvature of the Earth? And this is apparently this person, Shirley, had a grandson who was stationed in Baghdad, Iraq, who was asking the question. And he goes to explain, it's 8 inches per mile, blah, 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 but it's not, 6 feet is 72 inches. So 8 times 9 would be 72. So you might be thinking, well, it's 9 miles. The dude would have to be 9 miles away for a 6-foot person to be obscured at 8 inches per mile. Well, no, it's not a slant. It's a curved. It's a ball. So you can't just, multiply 8 times the miles. And when they go through all the Pythagorean theorem and blah, 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 you end up with 3 miles as your answer. Okay? So at 3 miles now, and we'll go back to our chart here, assuming your eye level is at the ground, 3 miles, 6 foot is obscured. Now this is what's interesting. And I'll create a little animation here for you to be able to visualize what I'm thinking here. And I'll let you think this through with me. Okay, let's just imagine our world as a beach ball. All right, the lines of the ball clearly point out what so many in the Ball Earth camp are blatantly ignoring. A ball, by its very nature, demands that its surface immediately begins to curve downward and away from any point on it. So if we imagine Poser James here, I'm using a software called Poser, let's call him PJ for short. If we imagine him standing on the beach ball, the problem becomes immediately apparent. Okay, he's standing on a ball. Immediately the ball is curving downward and away from his feet in all directions. That's what a ball does. And it doesn't matter how big the person is, nor does it matter how big the ball is. But let's go ahead and shrink PJ and enlarge the ball for the sake of example here. Now, notice the lines are still curving downward and away in all directions, even though he's getting smaller and the ball is getting bigger. This never changes with scale. Okay, now let's zoom into tiny PJ on the massive ball here and consider the curvature word problem that was brought up by this individual serving in Iraq. If PJ was 6 feet tall and he had a clone, who's also 6 feet tall, right, who walked 1 mile away from him, the ground his clone would be standing on would be 8 inches lower than the ground that he was standing on, right? Again, the curvature math is 8 inches per mile squared. So the first mile, 1 times 1 is 1 times 8 is 8 inches. So the ground from point A to point B is going to be 8 inches below point A. All right, you with me so far? Now, if the clone had a clone who walked another mile away, that clone's ground would be 32 inches below PJ's ground. Why? Because it's 8 inches per mile squared. 2 miles, okay, 2 times 2 is 4 times 8 is 32. So the ground that clone number 2 is standing on is 32, almost 3 feet below the ground that PJ is standing on. And if we had yet another clone who was to walk 1 more mile, his ground would be 72 inches or 6 feet below PJ's. Thus, the top of clone number 3's head would be even with the bottom of PJ's feet. I know for some of you the gerbil just jumped off the wheel, so let's look at it again. This time we'll check it out from a different angle. Again, PJ's clone walks 1 mile away. The top of his head would be 8 inches lower than PJ's. Another clone walks an additional mile, and the top of his head is then 32 inches below PJ's. The third clone walks 1 more mile, and at just 3 miles away from PJ, The ground clone number 3 is standing on is 6 feet below PJ's. Thus, the top of clone number 3's head is going to be even with the bottom of PJ's feet. Now, I'm not trying to see whether or not the person can see the other person. What I'm trying to show you is the issue of the ground level. The ground level is the issue that I'm focused on with this example. Because if clone number 3's ground is 72 inches below the ground that PJ is standing on, it's going to be physically impossible for PJ to look straight ahead or to the left or the right or behind him and ever expect to see the horizon at his eye level. It cannot be done. I'm going to say it again. If you're just looking straight ahead, there is no way the horizon could ever be at your eye level. When the ground you're standing on is immediately beginning to recede away from you in every direction, you're standing on a point on a ball, supposedly. The ground you're standing on immediately begins to recede away in every direction 8 inches per mile squared. Now, I understand we're not on a perfect beach ball, but you actually compound the problem if you start using the argument, well, there are, peaks and valleys and hills and mountains and plateaus and canyons and blah, blah, blah. All you're doing is pushing the problem further out, and eventually you, the ball earther who uses this argument, are the one who's in danger of falling off the edge of something, because you can extend that out only so far, and then you're going to have to correct the terrain back to that 8 inches per mile squared so that you can have your 25,000 mile circumference ball. Or pair if you choose to go by Neil deGrasse Tyson. But for this math to be true, and it has to be in order to maintain a 25,000 mile circumference, no person could ever look straight ahead and expect to see the horizon at his eye level. But still, this is what we have to put up with.
The most important thing to understand is that the horizon is flat. That's right. From our vantage point, even from a high mountain or an airplane, the horizon is flat. Flat earthers, and also many globalists, for lack of a better term, seem to think that the horizon should look curved to us. That's flat wrong. And I think this is the single biggest reason there even is a flat earth community, the biggest source of confusion. You are expecting to see a curve where there is none to be seen. You are looking for the wrong thing. To picture what I mean, look at this orange. If I take a thin slice of it, I get a round disc. The edges of it, where the knife cut through, is a flat circle. That is what you see when you look at the horizon, the edges of a circle. The edges don't curve side to side, they run straight across our view. And since we are always in the center of the circle, they don't curve down.
My first question is, why is this dude wearing fingernail polish? But I guess everybody's entitled to their thing. But my other observation was, after he said, if I take an orange and slice it off, sorry, you can't do that. If your orange is representing the Earth, you've got to leave its spherical nature intact. You can't slice off the top of the sphere that you're using as your example and then say, that's why everything's flat, because I just sliced off the curve. I don't know. Anyway, let's go back to Captain Fingernail Polish and see what other piece of amazing logic he has for us.
When you can see the horizon in all directions, it is the same distance away in all directions. So when you spin around, it looks exactly like a straight line and comes back around to join itself. Think about that. If it were curved down, it would not come back around and join itself at the same level.
Exactly. If it were curved, it would be dropping off 8 inches per mile squared from every point upon which you are standing. That is inescapable ball earth math. Wow. But, okay, to be fair, I do understand what Captain Fingernail Polish is saying here. This is a typical argument that I've heard lots of times, actually. Ball earthers will claim that just like the blue circle at the top of the beach ball here, that's the visible horizon. So from whatever point you're standing on, and you're looking out toward the horizon, in 360 degrees, that line is going to be the same. It's always going to be right there. But as I'm showing you, That only works if you're looking down. I don't care how big the ball is. I don't care how big you are. I don't care how small you are compared to the ball. If you're standing on the ball, the point at which you are standing, from that point outward, is receding downward at an exponential rate. Downward. Which means you can never look out to this mystical circle out in front of you at eye level. It cannot be. It can't happen. So this whole idea right here, while in principle it sounds good, looks good, but it's a myth. It does not exist in the observable, testable, and repeatable example of reality. According to Pythagorean math, the 25,000-mile circumference ball Eratosthenes invented does not allow for us to ever be able to see the supposed edge of a horizon that presents itself at eye level. Yet whether we're on the ground or flying up to 37,000 feet in an airplane or sending up a weather balloon to over 100,000 feet, there's that totally flat horizon straight ahead at our eye level. Always. That's simply not possible if it's receding downward and away from us at a rate of 8 inches per mile squared, which is what it must do. But once again, in reality, we don't see this. Therefore, this whole idea that's depicted here and that was depicted with the slicing of the orange, that whole idea is a myth. It doesn't exist in reality unless you're looking downward, which I don't know about you, but I don't go around in my everyday life looking at the ground. I stand straight up and I look straight out, and there's the horizon at my eye level. Not possible with Pythagorean math on Eratosthenes' ball. And speaking of myths, people who think ships are disappearing over the curve in less than 10 miles distance, it's got to work both ways. I mean, if we're on a ball, then when the ship is going away from you on the, let's say, the z-axis, going, from you to a point away from you, and it's rolling over the ball in less than 10 miles, then you should have the exact same effect looking left to right on the x-axis. You should be seeing ships rolling up to the top of the ball and rolling down on the lateral x-axis. If it's a ball, they got to be rolling both ways, away from you and side to side. We never see that though. You can go to the beach and do a panoramic shot and put a parallel line over it, and from end to end, and this is a lot more than just 5 miles, there's no perceived curvature here. None. Flat as a pancake. And in fact, these are some pictures I took on the beach at Malibu, California. And I went from there way up into the mountains above Pepperdine University and looked out. And easily there's got to be probably close to 100 miles left to right. The distance on the horizon there it's got to be, quite a bit there. Put a parallel line over it, flat. So you can't have it both ways. You can't say ships are rolling over the ball on the z-axis without having the same exact perception on the x-axis. I was thinking about that while we were on Lake Michigan. We were on the east coast of the lake looking toward the west. And so if you're standing on the east coast looking toward the west and you claim that ships are disappearing in 3, 4, 5, 10 miles, whatever, distance, then people who are standing on the southern coastline would make the same claim. If they're on the south looking toward the north, they would say the same thing. Well, I see ships disappearing in 3, 4, 5, 6, 7, 8, 9, 10 miles away. So if the person standing on the south coast looking north is claiming that ships are disappearing, and the person standing on the east coast looking west is saying the same thing, then both people have to observe the alleged curvature that the other person is claiming their ships are going over. Therefore, like I said, this whole idea of the eye-level horizon being equal, as depicted here, or as depicted when you slice off a piece of an orange, is a myth. All right, let's continue.
There's a handy website that will calculate the distance to the horizon for any viewing height, and it also tells you how much of an object will be hidden behind the horizon if it's past the horizon. The site is metabunk.org/curve.
So I went there, and this is the calculator that's there, and you can run all the same calculations that I showed you in the other websites. It works very much the same way. But this is what's interesting to me. Let's look at this graphic right here on the bottom. See, they always got this thing in the middle between the observer and the target, and it's called the bulge. And they'll have you believe that everything you're looking at is on the other side of a big hump, a big bulge. You're always going to have to walk uphill first and then walk downhill to get to wherever you're going. In all of these examples, it's always this way. Okay, they got this target, over here, and the observer over here, and this big bulge in the middle. And that's what all these ballers would have you believe, is that everything you're looking at is on the other side of a big bulge you're going to have to walk or drive or swim or take a boat or fly over to get to. And somebody else has done videos on how big that bulge would be if you're flying from like Los Angeles to Hawaii. I mean, it gets quite absurd when you start putting it into these terms. But let me just simplify all of this for you and bring PJ back into the picture. Now, he's standing on top of the ball, right? But I'm going to slide him over to the observation point here. Now, I'm keeping him perpendicular to the ground. Now, do you see the problem? The only way he could be looking toward the top of the bulge is if he's tilting his head down. He'd have to be looking down. He couldn't be standing straight up, looking straight out. The only way he's going to see the curve is if he's looking down. Let's keep PJ looking straight ahead, and I'm going to slide him down so that his eyeball essentially ends up on the ground, looking straight out, and you're going to see the problem here. Look, at ground level, if his eyeball is on the ground and he's looking straight out, the ground is beginning to immediately curve downward. There's no bulge. There's no bulge. Balls, it don't work that way if you're standing perpendicular on top of it and then you point on the ball. But yet every single curvature chart you're going to find is going to show this same kind of nonsense, where they either have the observer or the target at ridiculous angles, or they're forcing the observer to look downward, such as in this example. But there's also plenty of others that depict essentially the same thing. In fact, if you go back to the Channel 57 ABC News Report Skyline Skepticism, the Lake Michigan Mirage, you remember the weatherman said,
now we have a lot of web extras with this story. Log on to abc57.com after this newscast. You can see the time lapse, a short lecture by Dr. Rennie, and how you can calculate how far you can see to the horizon based on your location. Reporting live, I'm Chief Meteorologist Tom Coombs.
So let's check that out. Here on the website, scroll down, and he's got this link right here. How far away is the horizon? If you click on that, it takes you to this page right here. From Discover magazine, I guess. How far away is the horizon from bad astronomy? That's properly labeled, I think. Bad astronomy. It could also be bad geometry. So they've got this picture right here, to help you figure out the Earth's curvature. You got your little man here, in this case standing perpendicular to the ground, but he's looking down. He's not looking straight out. He's looking down. They always depict it that way. In fact, if we go to this other one here, Earth Curve Calculator, a lot of people like to use this one. This is the way it looks today. But I'm going to tell you that's not the way it has always looked. They've got the H0 or the observer here and the target perpendicular with the ground. But this is a recent change to the website. This is the way they used to depict it. They used to have H0 and H1 straight up and down, instead of perpendicular with the green line representing the globe. Here's a meme I created back on January 16th, and I posted it on Facebook. You see the problem here? Look at this graphic. Look at the way they have H0 and H1. See the angles? See the problem? That would mean that the person on H1 and the target are leaning inward, which means they're not standing perpendicular to the ground. They're leaning inward. I posted this meme on Facebook, and as I was making this video and getting ready to use this example right here, guess what? Okay, I posted this January 16th, and here it is February 2nd, and I go to this website and it's changed. So just to prove that they did this, somebody must have showed them the meme or saw something that either myself or somebody else was pointing out to mock this graphic. So they changed it. And here's the proof. You go back to the Wayback Machine, go back to October of last year, and what do you know? There's the original one. It was just, a few months ago that they changed, because they know that we're on to their game here. They know that what they're putting out is crap, but at least they're consistent. They're doing the same thing everybody else is doing. So let's go back to this other one from Debunked. Now I'm going to enlarge this graphic and orient it so that PJ is standing straight up and down again, and lower him so that he's within the observer square. Now this is what they're saying. This is the observer looking toward the horizon. But unlike their example here, where they're forcing the observer to look downward toward the horizon, my observer is in their little square looking straight out. And from the feet of my observer, the ground is curving downward, just like it would do in real life if we're standing on a ball. For those of you who are interested in doing so, here's a simple test, and it doesn't require that you be a Freemason, a Luciferian, a Nazi, an occultist, or an atheist. You don't even need to have a college education or a lot of money. What you need to do is get a long pole that would facilitate putting something up to your eye level. In this case, I've got like a 4x4 with a plank of wood on top of it. Make sure the vertical post is vertically level, and make sure the horizontal plate on top of it is also level. And then go get some paper towels. Use the paper towel tube. You can even keep the paper towels on it if you want to. But if you have just an empty paper towel tube, you can set on, tape to the top of it, and then stand behind it such that your eyeball is looking right through it. And then just look straight ahead through this forced experiment right here that keeps everything looking straight. And I would suggest you do this at a beach somewhere, so you don't have to deal with the topography of the land. You're going to know that there aren't any peaks and valleys, mountains and canyons or whatever on the ocean. You're going to have a straight, flat horizon. And if you do this, you're going to see the horizon is going to be right there. It's going to be right as you're looking through that tiny little field of view through that paper towel tube. You're going to see the horizon is going to be at eye level. And yet we've just shown you that that is physically impossible. That cannot happen. The ground has to be dropping away from you, receding downward in every direction from the point at which you're standing. That's the way it works on a ball. That's the way the ball earth math works. According to Pythagoras and according to the spherical model invented by Eratosthenes, who calculated our circumference to within about 5% of its currently accepted circumference of 25,000 miles by looking at the sun in a well and the shadow of a phallic symbol. So as you can see, this produces an extremely interesting problem for the ballers. And frankly, it means that Pythagoras and Eratosthenes just handed a trump card to the flat earthers. And pardon the pun, but there's simply no way around this problem. Indeed, if the squares of a chessboard are 1 mile across, all it takes is 3 moves for any flat earther to quickly put a ball earther into checkmate. Thanks so much for watching. I hope you enjoyed this video presentation. If you did, please subscribe to my YouTube channel, like the video, and share it on your favorite social media sites. There's a lot more to come, so stay tuned and we'll see you back next time.